Hi, my name is Marissa Mannon, and today we're going to look at the quadratic equation. So what we see right here is the standard polynomial equation that we all know, ax squared plus bx plus c, the a, b, and c being the coefficients. Now when we're factoring, sometimes it's not going to go as easy as it has for some of the previous examples that you've done. Like in this example, you might start by finding two numbers that would multiply to the a and c term multiplied and add to the b term. That would give -4 and -4. Now there's no two numbers that would add up to -4 and would multiply to -4. So you can't do it by this method. So what you'll do when all the methods won't work that you know so far is use the quadratic equation. It's opposite b plus or minus the square root of b squared minus 4 times ac all over 2 times a. So if we take the example we just saw that wouldn't factor very nicely and put that into the quadratic equation, we get opposite b, so it's positive 4 instead of -4, plus or minus the square root of b squared, which is -4 squared, minus 4 times the a term times the c term. And that's all over 2 times the a term. So, simplifying that further, we have 4 plus or minus the square root of 16 plus 16, all over 4. From this, it will be 4 plus or minus the square root of 32, all over 4. So now, to get you two answers of what x will be, you just take into consideration the plus and minus. So for 1, we'll have 4 plus the square root of 32 over 4, and 4 minus the square root of 32 over 4. This next example, we'll do the same thing. Opposite b, so -6 plus or minus the square root of b squared, so 6 squared minus 4 times the a term times the c term. And that's all over 2 times the a term. Simplifying this further, we have -6 plus or minus the square root of 36 minus 36 over -2, which gives us -6 plus or minus the square root of 0 over -2. Now, taking into consideration the plus or minus, we know that the square root of 0 is just 0, and that adding or subtracting 0 from the -6 would both give us -6. So we're going to end up with one solution, -6 over -2, which is 3. So x equals 3. Now, one other thing is the discriminant, and this is going to tell us how many solutions one equation will have when we use this quadratic equation. You plug in the coefficients of the polynomial into b squared minus 4ac, and that will tell us how many solutions it has. If the value you get is positive, there's going to be 2 real solutions. If it's 0, there's going to be 1 real solution. And if it's negative, there will be 2 complex solutions using I. Now we can prove this a little bit with the 2 examples that we've done so far. So the discriminant is b squared minus 4ac. So in the first one, we have -4 squared minus 4 times 2 times -2, and that ends up being the 16 minus negative 16, which gives us a positive 32. So there would be two real solutions. Now, in the other example, we have 6 squared minus 4 times negative 1 times negative 9, which ends up giving us 36 minus 36, which is 0, which is why we got one real solution when we solved it in the previous example. Alright, so if we were going to graph a polynomial, you first need to turn our standard polynomial form into what we call vertex form. So A will stay the same, and then we're not going to have the B and C coefficients anymore. We will instead have something called H and K. So to find H, you simply do equation of opposite B over 2A. So that will be your H, and then K will be whatever you get when you plug in what you got for H into the original standard form. And once you plug H and K into the equation, A times x minus H squared plus K, that shows us what the vertex is, which is the highest or lowest point on the graph. Now, if that was a little confusing, we'll do an example. Alright, so we need to turn this into the other form, the vertex form. So we need H and K. So for H, which was opposite B over 2A, we're going to have negative 12 over 2 times 3, which is going to give us negative 2. And then we also need K, which is going to be the function when H is plugged in, which is also saying the function when negative 2 is plugged in. So we have 3 times negative 2 squared plus 12 times negative 2 minus 15. Now this turns into 12 right here, minus 24 minus 15, which simplifies to negative 27. So now we have our H and our K values. So when we plug that into the equation that we had, we're going to have the A term times x minus the H term squared plus our K term. Now this double negative right here is going to turn into a plus, and this one is going to turn into a minus, just with simple rules. So we'll have 3 times x plus 2 squared minus 27. Now how we get the vertex from this will be setting the parentheses equal to 0. So x plus 2 equals 0. You'd subtract 2 from each side. So x is going to be negative 2 as the vertex. And then the y coordinate is just going to be the k value. So the y is going to be negative 27. So our vertex is negative 2, negative 27. So to graph this, so we plot the vertex first, negative 2, negative 27, which would be around here. Then you would plot like you normally would, pretending that the vertex is the origin. So we'll take the equation 3x squared and pretend that we're doing it in the origin. So when you move over to the right 1, you're going to go up 3x squared. So 3 times 1 squared is going to be 3. So we're going to go up here. Put that on the other side. And then when you go over 2 to the 0, you're going to go up 3x squared, so 3 times 2 squared, which is 12 up, which would bring you to about 15. And then reflect that onto the other side. And then for the time being, we'll just sketch the rest of the polynomial, but you would keep following with how to graph, pretending that it's the origin. And then one other important thing to know is that the a value in ax squared, when you're looking at the normal polynomial or the a value in the vertex form, is that the larger it gets, the larger the values will squish the curve inwards. Smaller values will expand it outwards, and then negative values are going to make the entire curve flip upside down. So if we looked at, if the a value was 1, that would be this light blue curve here. And then making the coefficient bigger, so making it 2x squared, which is this yellow, it squished it inwards. So now it's steeper. If you made the a value smaller, which is going to be this dark blue curve, that's going to expand it outwards, which is why it's pushed outwards. And then negative values be like this lime green color down here, and that turned the original x squared upside down, just mirrored it over the x-axis.